What is desalination? Desalination is the process of removing salt and minerals from seawater to make it suitable for drinking, agriculture, or industrial use, including mining. Converting seawater into water safe for human consumption or irrigation is a critical technology. What methods of desalination exist and how do they work? There are two primary seawater desalination technologies: membrane-based reverse osmosis and thermal processes. Each has its advantages and drawbacks, but both require energy to produce fresh water. Reverse osmosis is the most widely used method because it consumes less energy. It relies on ultra-thin polyamide membranes that allow water to pass through while blocking salt. However, these membranes can become contaminated with bacteria, so pre-treatment of the water is necessary. Thermal desalination, on the other hand, works by heating seawater until it evaporates, leaving impurities behind. The vapor is then condensed back into liquid. While effective, this method is more energy-intensive than modern membrane technologies like reverse osmosis due to the energy required for phase changes from liquid to vapor and back. Currently, 56 billion liters of desalinated water are produced daily, equivalent to about 7 liters per person globally. Of the 16,000 desalination plants in operation worldwide, 39% are located in the Middle East, where water scarcity is most acute. Countries like Saudi Arabia, the UAE, Kuwait, and Israel lead the way, leveraging their financial resources and energy supplies to rapidly expand desalination infrastructure. While desalination alone cannot solve the global water crisis, it plays a vital role in providing clean, safe drinking water, as well as water for industrial and mining purposes. Why is desalination important and what are the benefits? Desalination enhances water security by turning seawater into a reliable local water source for drinking, industrial applications, and irrigation. This reduces the reliance on freshwater resources, which is especially critical in regions suffering from droughts or water shortages. In mining, desalinated water can play a significant role, with some jurisdictions considering tying mine permits to the development of desalination plants, ensuring that mining operations do not compete with freshwater resources needed for human consumption. What are the issues with desalination? Desalination processes are energy-intensive and costly, making them unsuitable for certain areas. Without renewable energy sources, desalination can increase fossil fuel dependence, exacerbate greenhouse gas emissions, and contribute to climate change. Additionally, desalination produces significant quantities of brine, 1.5 liters of brine for every liter of potable water. This brine often contains pollutants like chlorine and copper, and its disposal back into the ocean can harm marine ecosystems. Brine discharge raises sea temperatures around the outlet and introduces thermal pollution, further endangering marine life. Despite these challenges, desalination could be a game-changer for mining by providing an additional, sustainable source of water. This would allow mines to operate without competing with freshwater resources needed for human use. Invest in the clean energy future. Invest with Talk Capital Management.